Welcome to this video. In today's video, we'll be looking at heat transfer and an example calculation. First of all, it's good to visualize what we'll be doing today, and we're using the PhET interactive simulator. And this particular simulator is the energy forms and changes. So let's just access that. Okay, once we get to the main menu, we're selecting the intro. And there we have it. So what we've got here is a selection of different materials, including water, olive oil, iron, and brick. And we've got supplies of heat and supplies of cold. We can grab a thermometer and attach that to the iron. We can grab a thermometer and attach that to the water. We can also have a look at the energy symbols. So we can see here in this situation, when we apply heat, heat's being added from our source into the metal, and the temperature goes up. Likewise, we can place this water on an ice source, and heat is being transferred from the water into the ice block to cool it. You notice also there's heat escaping from the iron block. So in this particular example we're going to try today, we want to place a piece of metal, in the actual example it will be an unknown piece of metal, into water, and we notice that energy is transferred from the metal into the water. And you can see the end result of this is an equilibrium temperature. That being that the final temperature of what was a hot piece of metal is now equal to the final temperature of what was a cold sample of water. Both metal and water end up at exactly the same temperature. In the upcoming example, we're going to use both the mass and the change in temperature for the unknown metal and the water to calculate the specific heat capacity of our unknown metal. Our example is a 75 gram sample of an unknown metal at 100 degrees Celsius is placed in 200 grams of water at 10 degrees Celsius. The final temperature of this system is 16 degrees Celsius, and we're asked to solve for the specific heat capacity of the unknown metal. So let's write down our information. So from the unknown metal's perspective, which is starting as a hot object, we're trying to find its specific heat capacity. We know its mass to be 75 grams, or if we divide by 1,000, 0.075 of a kilogram. And of course, the equation we're going to use requires the mass to be in kilograms. Its change in temperature, it starts at 100 and it cools down to a final temperature of 16 degrees, which gives me a change, delta T, of 84 degrees Celsius. That's the information for our metal. Now let's consider the information for our water. So there's the information for our water, which is starting as a cold object. It has a specific heat capacity of 4,200 joules per kilogram per Kelvin, which is textbook out of the table. Its mass is 200 grams, but when we divide that by 1,000, we express that as 0.200 kilograms. Again, we need our mass to be in kilograms for the calculation we're about to undertake. And the change in temperature, it's elevated to a hot temperature of 16, and it started at 10. Its change in temperature is 6 degrees Celsius. Note that I'm not worried about whether or not my change in temperature is an increase or decrease. I'm just looking for an absolute value. The delta T for the metal is 84 degrees Celsius and the delta T for the water is 6 degrees Celsius. Now let's write a statement. Okay, in this scenario, we know the energy being transferred from the metal will be equal to the energy transferred to the water. Let's express this mathematically. Okay, MC delta T for the metal is equal to MC delta T for the water. Now in this example, we're being asked to calculate the specific heat capacity of the unknown metal. So let's rewrite this and make C of the metal our subject. So there we have it. In order to get C by itself, we must divide the mass and the delta T from the metal across to the right-hand side. So our expression now, to work out the unknown specific heat capacity of the metal, it will equal to the MC delta T of the water divided by the M delta T of the metal. Now to find this value, we simply need to substitute our values into this equation. Okay, our numerator comes from the information from the water, and our denominator comes from the information from the hot metal. So when we do our calculations, we find that the unknown specific heat capacity of the metal is 800 joules per kilogram per Kelvin.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.